Hello, thanks for joining us here at AutoSens. My name is Jeff VanWashenova, and I'm the Director of Automotive Segment Marketing at CEVA. This is our seventh time attending AutoSens, and it's a great venue to, number one, meet a lot of you, and then also this morning we announced a new product, which is NeuPro-S, which is dedicated for AI and computer vision processing on the edge. So today I wanted to first talk about CEVA, who we are, what we're doing in automotive, and then talk a little bit about NeuPro-S, which is our new product and some of the features of our second generation AI processor. So who CEVA is we are a silicon IP company. We actually are a publicly traded company on the NASDAQ. We've been licensing technology since 1991. We have about 400 employees now. Our headquarters is in Mountain View, California. We have R&D centers in Israel, France, the US, and the UK. And we focus on some very important technologies within automotive. So we focus on long-range communications, so those are things that are like LTE, 5G, DSP platforms. Short-range IoT connectivity, so that's Wi-Fi and Bluetooth. In automotive, we focus predominantly on AI at the edge and computer vision. And then we just acquired a company by the name of Hillcrest Labs, who's focusing on sensor fusion. I'm going to talk a little bit about our technologies in automotive, but first I wanted to talk about our strategic partnership with Immervision Technologies, who's the booth right next to us. CEVA, Immervision is actually focusing on a couple of areas within automotive. One thing is wide-angle optics, sensor fusion software, and then also image processing algorithms. CEVA has the exclusive licensing rights of both the image processing algorithms and sensor fusion, which include data and picture. On the imaging processing side, those are things like active dewarp, distortion correction, and multi-camera stitching. So if you would like to have conversations about Immervision, please come see CEVA and Immervision. Where CEVA plays in automotive is we've had a lot of success in automotive, mostly on the vision side, where we have design wins today with things like front view camera systems, surround view, blind spot detection, and then also driver monitoring systems. We are also very strong in the cellular communications. We have design wins for both cellular V2X and also DSRC. Working in both radar and LiDAR, that's both the front end processing and also doing things like object detection and segmentation. And then we also have design wins in connectivity, so Bluetooth and Wi-Fi, and then working with some strategic partners on automated driving. So where CEVA started in automotive is we came out first with computer vision technology, which was the CEVA XM4. We have silicon that will be in the market this year with XM4. XM4 is also includes with a graph compiler, which is the CDNN technology, which is CEVA Deep Neural Network technology. All of our designs are ISO 26262, and that includes the silicon that we're launching in the market today. Last year we announced our first dedicated AI processor, which was called NeuPro. And then earlier today we announced the second generation of NeuPro, which is called NeuPro-S. Along with NeuPro-S, we also announced an industry-first CDNN Invite, which is a software compiler technology that is able to integrate customer custom AI engines into the CEVA software tool framework. So why did we design NeuPro-S? So some of the market trends that CEVA realized in working with our customers and added these particular features to NeuPro-S. We kind of had to do a reframing in the automotive industry when it comes to AI. So early on, everybody thought AI could do everything. And so we've learned that AI is very useful. So it's very good, it's robust for detection, identification, segmentation, but AI doesn't solve all the problems. So it's important to have both AI solutions that are integrated tightly with computer vision solutions. So you still need computer vision for image enhancement and redundancy, reliability, and CEVA's platform basically has both parts, both computer vision and artificial intelligence. The other trend that we want to talk about is where we got our CDNN Invite API is many semiconductors and OEMs want to use their own custom hardware accelerators. So this adds differentiation. The challenge is how do we keep these solutions current how to scale the solutions, and then finally how to get a mature tool chain. And then this CEVA CDNN invite addresses some of those trends. So looking at the NeuPro-S AI processing proposition, it's a scalable solution that scales anywhere from 2 to 100 teraops, so I'll speak about that in a little bit. It is automotive safety standard compliance. So we have our neural network interface compiler, which is called CDNN, and then we also have the new CDNN Invite API, which integrates custom AI engines into the CEVA framework. Over our last NeuPro, we have been able to achieve 40% system memory savings, 40% reduced memory bandwidth, and then also 30% energy savings, and then finally 50% improvements in higher performance. What the NeuPro-S is a complete platform which includes hardware and software. On the hardware side, it's comprised of 2 pieces. One is the NeuPro-S engine, and the second piece is the CEVA XM DSP. So we utilize both the engine and the CEVA XM DSP for one, efficiency on the engine side, and then flexibility on the CEVA XM side. In addition to the hardware, we have a CDNN compiler, which is a tool that takes fully trained neural networks and targets CEVA-specific application cores. And then we have a CDNN runtime, which is used in the runtime environment to execute those neural networks on CEVA cores. Just to quickly go through this, because it's a bit of an eye chart, but this is the system diagram of a single core of the CEVA engine. It's comprised of CEVA XM6, which is used for flexibility, and the NeuPro-S engine, which can do acceleration of convolution, activation, and cooling. And then we've also added the ability to do weight sparsity decompression. We've increased the interfaces to free up bandwidth. And then we also have, via software optimizations, L2 memory utilization. Then of course, all of CEVA cores are ISO 26262 compliant. In order to scale NeuPro-S, we have a cluster concept. We're able to cluster a number of CEVA cores. So this is just an example of using multiple CEVA XM NeuPro-S cores, along with custom AI engines provided by third-party companies. So this is an example where we can scale up to and over 100 teraops utilizing multiple clusters of CEVA cores. So with the NeuPro-S, we have a couple of varieties of NeuPro-S. So to scale further, either addressing different markets, so we have NeuPro-S 1000, which includes 1024 8x8 max, and then we go up to NeuPro-S 2000 and 4000, which is 2048 and 4096 max respectively. So this allows us to be able to address multiple markets, anywhere from low-end automotive doing rear backup cameras, all the way up to level 3 and above self-driving applications through scaling of NeuPro-S cores. And then finally, I wanted to talk about the CEVA Deep Neural Network Framework. I spoke about this before, but we also have a new version of this, which is the CDNN Invite. What CDNN does, it's a network interface graph compiler, which takes fully trained neural networks and targets specific configurations of CEVA cores, and now also targets custom AI engines that may be designed by either OEMs, tier 1s, or third parties. So why we wanted to have the CDNN Invite rationale is there's a lot, in regards to differentiation in the market, many OEMs, tier 1s, and third parties have their own custom neural network accelerator. Where they lack is maybe being able to provide tools or mature tool chain that customers can program these third-party accelerators easily. So with CDNN Invite, this enables silicon designers both to differentiate via their custom AI accelerators, but it allows us to utilize a mature tool chain like CDNN. So what this does is basically we have a CDNN compiler and scheduler. We have the CEVA XM device and the NeuPro engine, and via a device API, we can add a custom neural network engine device to the CEVA framework. So a number of architecture examples, if we look from the left to the right, this is the native approach where a customer will utilize the CDNN compiler and scheduler, and then also use CEVA XM along with a NeuPro-S device. The second is where a customer may want to utilize CEVA XM for computer vision, but wants to use their own dedicated neural network accelerator, and the CDNN invite enables that customer to use his own hardware accelerator in a mature tool chain like CDNN. And then finally, CDNN invite, this is actually an automotive example. We have a customer who's doing this today, where he's utilizing a CEVA XM. He wants to utilize the NeuPro-S for flexibility and future-proofing his design. And then he has his own, and then they have their own custom neural network accelerator, which we're able to utilize the CDNN invite so that they can program the device in a mature tool chain. So that's all I have today. So thank you guys for joining, and we'll take questions.